In this example, we are going to find the volume of a solid in the first quadrant, generated by rotating around the line y equals -1, which kind of messes things up a little bit, makes it a little more challenging because we're not rotating around the x-axis, but bounded by this square root of x plus 1 and the quadratic of x squared plus 1. All right, so very much need a visual to this, see what's going on. I just want to make a little bit of a bigger visual than normal. All right, so we are going to be rotating it around this line right here of y equals -1. And then if I look at these graphs, this is a square root graph shifted up 1. And then if I square root, because I got to figure out my bound. So if I take this equation and set it equal to this equation and solve it, or I can kind of do this visually, that if I square root 1 plus 1, I get a 2. And if I take 1 squared plus 1, I get a 2. So they're going to cross each other at this spot. My square root graph is going to look like this. That's my square root of x plus 1. And my quadratic is going to look like that. So I have an x squared plus 1. Okay, and so we are going to be taking this shape and rotating it around, not the x-axis, but we're going to be rotating around this line of y equals -1. So we're going to rotate it around. We're going to have this big gap in between it. It's going to create some sort of a shape to it. So what I need to figure out is we're going to be doing the big radius squared minus the small radius squared. All right, and so it's going to be dependent upon where we would be rotating it. And so the big radius is going to be from here all the way down to here. So that's the big R, right? So that big radius is going to be made up of this. And we can logic our way through it, but sometimes it's going to get tricky. So we need kind of a method to this, that whatever this height is, which is this piece, I'm going to be extending it by 1. So the math is really I can take this piece and I can add 1 to it. But sometimes it's going to be a little trickier if like we're rotating it something up above. But we're always going to take, and here's kind of the logic to it, that if I want to find a distance between two values, here's a distance between two values. Even if I do a number line version of it, I'm going to take the larger value, which would be this is the top. So I'm going to take the larger value and I'm going to subtract the smaller value, and it turns into an addition on this particular because we're subtracting a negative, which is if I take the higher value, so my big R could be us taking the higher value minus the lower value. And you'll see the math works out perfect. I don't have to logic my way through it because it gets tricky sometimes. And so this just turns into the square root of x, and that minus a -1 is how we add the 1 to it. Right, so the math agrees with that. So our big radius is going to be made up of this equation. Right, so when we do our volume, our volume is going to be pi times big radius square root of x plus 2 squared minus little radius. Little radius is going to be this distance. So this is our washer method. We're going to find this big volume and we're going to be subtracting out the small volume, and what we'd have left would be this shape kind of rotating it around. So small r is going to be exact same idea, that we have this height minus the -1. So the top equation minus the bottom equation. So x squared plus 1 minus the bottom equation. And again, this ends up adding 1. So we're looking at an x squared plus 2 for our little radius. So little radius, x squared plus 2 squared dx. All right, so here's our math. Our bounds is we're going to go from 0 to 1. Right? That's where they intersect each other. All right, so let's do the math on this. So everything looks good. Let's take the pi out always. We're going to go 0 to 1 of this equation. Let's go ahead and multiply it out. Let's multiply it out and see if we have any like terms that we can put together. Because it's a square, if it was a cube, maybe we take a different approach to it. But since it's square, we're going to take this times itself. So we're going to get square root of x times square root of x. We're going to get a 2 square root of x plus another 2 square root of x. So plus a 4 square root of x plus 2 times 2 is 4 minus, so let me put, there's the first equation, minus the second equation is going to be x squared times x squared, x to the fourth, 2x squared plus another 2x squared is plus 4x squared, and then 2 times 2 is 4. Okay, so let's see what we can put together, and then we can do our antiderivative. So 0 to 1, let's start with our highest power. So if I distribute this negative in, I'd have a negative x to the fourth, which won't combine with anything. And then I have a negative 4x squared. And then I'd have a positive x, because it wouldn't combine with anything. I have a 4x to the 1/2 power to get it ready to do the antiderivative. And then my last would be these two, but this would be a 4 minus a 4, so that would go away. All right, so here's what we're going to do our antiderivative of. So if I do our antiderivative, we'll keep our pi in the front. We'll add a power, divide by the power. So negative x to the 5th over 5. And then minus 4x to the 3rd over 3 plus x squared plus we'd have a x to the 3/2. And then I would take the reciprocal of this and multiply it to 4. So the reciprocal of that, instead of dividing by 3/2, we multiply the reciprocal. So that would be 2/3 times 4, which would be 8/3. All right, and then we're going to go from 0 to 1. So we'll plug some ones in, and then plugging the 0 in won't do anything. So we plug a 1 in, we're going to get a negative 1/5. Plug a 1 in, we're going to get a 4/3. Plug a 1 in, we'll get a 1. Plug a 1 in, we'll get an 8/3. All right, so let me brackets around things. So there's plugging the 1 in, minus plugging the 0 in. All this stuff goes away. Just a 0. All right, so now the fraction part. We have a common denominator of, I added a power divided by my power. Sorry, it should be a 1/2. Okay, better. All right, so we can get a 15 out of that, but multiply it by 2, we're looking at a 30 for our common denominator. So if we make this into a 30, we're looking at a negative 6/30 minus a 40/30 plus a 15/30 plus an 80/30. All right, so if we add all that stuff together, that would give us a 49/30. We'll tack our pi onto it now. So 49 pi over 30. And that is our volume of this. It got a little tricky because we weren't rotating around an x-axis or a y-axis. And so we had to account for a little extra volume that would be created as we kind of go around. It'd be a bigger circle than we originally would have had if we were rotating around an x-axis.